So we're going to be talking about trigonometric ratios. Historically, this is a tough lesson. We're going to be talking about sine, cosine, and tangent. First of all, when we talk about trigonometry, we're talking about the relationships between sides and angles of triangles. And very specifically in this lesson, we're going to be focusing on a specific type of triangle. So trigonometry is really all triangles, but this trigonometric ratio lesson is focused in on just right triangles, okay? And a trigonometric ratio is just the ratio of two sides of a right triangle. So think about what we're doing for a second. We're locking in one of our angles to being 90 degrees, and we're just going to assume that that angle is 90 degrees, okay? And then we're going to have another angle that we know that we're going to be concerned with in a right triangle. If we know the measure of one of the other angles, that third angle is locked in to being whatever makes all three angles, the 90 degree, the one that we know, and the third angle, all of them have to add up to 180 degrees. Because we're working with something that's so fixed, so locked into place, what we're going to be finding is that the ratios of sides for a particular angle are fixed. Okay. So let's say, for example, I'm looking at a 22-degree angle on a right triangle. I'm not going to talk about it for a whole lot, but if I have a 22-degree angle on a right triangle, that means that my third angle has to be 68 degrees. But it doesn't matter. We're looking at the 22-degree angle. Okay. That there is going to be a side of the triangle that's opposite from that 22-degree angle. And then that right triangle is also going to have hypotenuse. If I have a 22-degree angle right triangle that has a specific hypotenuse length, there is only one other opposite side length that works for that particular triangle. Or another way to think about this is if I have a 22-degree angle in a right triangle, there's an infinite number of opposite side and hypotenuse lengths that could make a right triangle, but they're always going to be in the same ratio to each other. So what we say is the sine of angle A, okay? Sine is not a mathematical operation like I can just multiply angle A by something or I can divide it by something or anything like that. All I'm saying when I say the sine of angle A, it's like, okay, go look up in a table for a 22-degree angle. What is the ratio of the opposite side to the hypotenuse? And there's going to be a ratio for a 22-degree angle of a right triangle of the opposite side of the hypotenuse that's always going to be the same. Now, here's the thing. Your calculator has these ratios built into it. It is a way of figuring out the ratios for any angle. So when you punch in the sine of 22 into a calculator, it's going to give you a decimal value. It's going to be somewhere between 0 if it's not really a triangle and 1 if it's not really a triangle, or any decimal number in between if it is actually a triangle. The ratio of the opposite side of a right triangle to the hypotenuse is always going to be a number less than 1. Why is that, by the way? Well, think about it. The hypotenuse is the longest side. So the longest side on the bottom of a fraction means we're always going to be dividing by a number bigger than the top number. It has to be a decimal. The cosine for a 22-degree angle is going to be dealing with different sides. Instead of dealing with the opposite side of the hypotenuse, it's going to be dealing with the adjacent side of the hypotenuse, okay? But same concept. And the tangent is the opposite over the adjacent. So let's draw a right triangle, and we're going to take a look at what these different ratios mean for a right triangle. So let's say that I am going to take a look at angle. By the way, when I say the sine of A, I'm talking about the sine of angle A in this triangle. And let's say that this particular triangle has a 22-degree angle here. Now, if I know it has a 22-degree angle, I know that this is going to be a 90-degree angle because it's a right triangle. This has to be 68 degrees, but I don't concern myself with that. I only use the angle measure that's given when I figure out sine, cosine, and tangent. Okay, if I'm given 22 degrees, I'm using 22 degrees. I'm not going to worry about finding the complement. Now, let's say that I wanted to know this side of the triangle. x over here. And let's say that I knew that the length of the hypotenuse of this particular triangle was 10. So let's say I knew that this was 10. Am I able to figure out the length of the unknown side? As long as there's just one unknown, yeah, I am. Okay, so what am I going to use? Well, okay, so let's take a look. This x here is the opposite side from my angle. My angle opens up to the opposite side. This side down here would have been the adjacent side because it's part of the 22-degree angle and it's not the hypotenuse. And then the hypotenuse is always the hypotenuse, just the longest side, right? So which one of these ratios involves the opposite side and the hypotenuse? Why, it's the sine of A. So the way I write this is the sine of 22 degrees, okay, equals the opposite, which is, in this case, is our unknown. So the opposite is x over the hypotenuse. If my hypotenuse was the unknown, then my unknown would be on the bottom of this fraction. But it's the opposite side that's unknown. All right, so now I'm going to solve this for x. To do that, I'm going to multiply both sides by 10. X equals the sine of 22 degrees times 10. Multiply both sides by 10. All right, now how do I find the sine of 22 degrees? You have to use a calculator. That's why you're required to have a scientific calculator for this class, okay? So it's going to be the sine of 22 degrees times 10. By the way, let's just do the sine of 22 first. Now, here's a trick. Some calculators are set to radian mode. Maybe you want to just double check in your calculator right now that when you do the sine of 22, you don't get this number. You should never get a negative number, okay? If you get a negative number, you're probably using radian mode instead of degree mode. I have to change this to degree mode and then run the calculation again, okay? And when I actually punch this into a calculator, it's going to look like this. Sine 22 equals. Now, some calculators, you have to enter 22 first and then press sine, and it will show you the sine of 22 degrees. You make sure that your calculator gives you something that looks like this. What does this number mean? Well, it means the ratio of the opposite side of the hypotenuse in a 22-degree triangle is 0.374. So for every 0.374 units of opposite side, I have 1 unit of hypotenuse, if that makes sense, or 0.375 if I rounded correctly. I need to multiply this number times 10. Okay, notice it defaulted going back to radians. Ooh, that's going to give me a problem in my Google calculator. I might just have to type degrees here, and now it knows I'm dealing with degrees. 3.75 is my answer. So this would be x is 3.75 if my hypotenuse is 10 in a 22-degree right triangle. That's how you do this. Now, you have to remember that sine is the sine of an angle. The sine of the angle is the ratio of the opposite over the hypotenuse. The cosine of an angle is the ratio of the adjacent over the hypotenuse. How are you going to remember that? Well, there is a phrase that you can use to kind of help you remember. SOHCAHTOA. SOHCAHTOA. So, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. By the way, tangent is the only one that can be a number that's greater than 1. Tangent can take on any value from negative infinity to infinity. Okay, so it can take on any value, any real number, because the opposite and adjacent can be bigger or smaller than each other. It doesn't matter. All right, let's take a look at some practice problems here. What is the sine of angle T? Now, when you're asked like this, just to find the sine of an angle, the sine of T is going to be, let's see, opposite over hypotenuse. SOHCAHTOA, opposite over hypotenuse. So I'm looking for angle T. I find the opposite side from angle T. 5 is part of the angle, so that's the adjacent side. 13 is hypotenuse. I can't use that, so it's going to be 12 over 13. The sine of angle T is 12 over 13. All right, that's letter A. That one was easy, right? Kinda, but it's kind of hard to remember what you're doing in these. Let's take a look at B. Okay, what is the tangent of angle U? The tangent of angle U is the opposite. So tan U equals the opposite from U, which is 5, over the adjacent side to U. The adjacent is not the hypotenuse. It's 12, 5 over 12. Okay? And then letter C for this triangle, find x to the nearest hundredth. This is the problem that's probably the most common when you're dealing with sine and cosine. So now we have to choose which one we're going to use. Which sides do I know compared to the 39-degree angle? Do I know the opposite side? Yes. At least I'm looking for the opposite side. That's my variable. Do I know the adjacent side? The adjacent side is blank. I don't care about the adjacent side. So I'm not going to use anything that has the adjacent side in it. Cosine, tangent are out. But I do know the hypotenuse. So the way I'm going to write this out, I'm going to write the actual expression, the sine of 39 degrees equals opposite x over hypotenuse, 41. Okay? I'm going to solve this for x. To get x on a side by itself, I'm going to multiply both sides by 41. So it's going to be 41 times the sine of 39 degrees. And then the only way to do this is to actually use a calculator. 41 times the sine of, is it 39? Yeah, 39, and I'm in degree mode in this calculator, not radian mode. Radians is just another way of measuring angles. We're going to use degrees instead. I get 25.8 to the nearest tenth, okay, equals 25.8. To the nearest hundredth, is it 0.80? It is 0.80. Let's just see if we get this one right here. Let's see. I don't remember where the answer was. There it is. Boom. All right. Now, the next ones are really easy. We just punch them into a calculator. That's all we have to do for D and E and F. Okay, so the sine of 30. We're going to get some surprising results from these ones. So the sine of 30, remember, this is a 30, 60, 90 triangle, and we know the ratio of sides between the opposite and the hypotenuse is going to be 1 to 2. So if I do the sine of 30, I get 1/2 because it's a 1, 2 square root of 3 triangle. So I just punched it into a calculator and calculated 0.5. The cosine of 90. Well, okay, we're talking about a right triangle. If I am doing a 90-degree angle in a right triangle, keep in mind, right triangle assumes one angle of the triangle is 90 degrees. And now I'm saying another angle is 90 degrees. This is not actually a triangle, but I can still calculate the cosine of 90. I'm just going to get a weird answer, okay? So we're going to do cosine of 90 equals, and we get 0. So I'm just going to enter 0. We kind of expected to get a weird answer for that. And then the tangent of 45. Well, remember, 45 is another one of those triangles. It's special, 45, 45, 90 triangle. So I'm going to do the tangent of 45 equals 1 because that's a 1. Remember, it's a 1, 1 square root of 2 triangle. So this is a 1-to-1 ratio. All right, and then finally, letter G. A playground has a slide that is at a 38-degree angle with the ground. The slide is 16 feet long. What is the height? And this diagram is what's important. I don't know why our book is so in love with the sine, but we're going to be using the sine of 38 to calculate this. It's going to look like this. The sine of 38 degrees equals, there we go, equals the opposite side, h, over the hypotenuse, 16. Which is going to be 16 times the sine of 38 degrees equals h. Okay, go to my calculator and do 16. So we're going to do 16 times the sine of 38 degrees. And we'll get an answer, 9.85. It said, let's see, so it should be 9.8, hold on. H equals, we'll put it over here, 9.85, and that's going to be feet. And let's just make sure we did that one right, 9.85 feet.